This is number 2 off of the FRQs for mock AP exam number 3. The figure to the right shows f prime. We have a derivative graph shown, and the values are between -4 and 5. And f prime, this f prime graph has horizontal tangent lines at -3, -1, 1, and 4. All right, so part A says find all the values of x between -4 and 5 for which f is increasing and justify your answer. And if we're looking at the derivative graph, I'm going to go ahead and start by labeling what I'm looking at. So anything above the x-axis represents where my original graph is going to represent positive slope. Anything below the x-axis represents where my original graph is going to exhibit negative slope. Anything on the x-axis are places where my original graph is going to display slope 0. So I'm going to create a slope sign line, and my endpoints being -4 and 5, my critical points being -3, 0, and 2. And in each interval, I'm going to indicate what's happening in terms of the slope of my original graph. So my original graph between -4 and 3, it's above the x-axis, so that's going to translate to the original graph showing a positive slope. Between -3 and 0, also showing positive slope. Between 0 and 2, all these values are below the x-axis, so that's going to represent negative slope. And then between 2 and 5, positive slope. So we can say, based off of this slope sign line, our function is increasing from -4 to -3, from -3 to 0, and then from 2 to 5 because f prime is greater than 0. Part B, find all the values of x between -4 and 5 for which our function has a relative max. So relative max, we can tell that the original graph is going to rise until 0 and is going to fall to 2 and then rise at 5. So we see that there must be a relative max at x equals 0 because f prime changes from a positive slope to a negative slope. Part C, find the values of x for which our graph is concave down. So if we want to create concavity or gather information about concavity or points of inflection, we're going to have to interpret this f prime graph accordingly. And the way we're going to do that is we're going to first pick out the peaks and valleys. The peaks and valleys are going to be places where points of inflection occur on the original graph. So here, if we're looking at the f prime graph, the max and mins are going to translate to points of inflection on the original graph. So -3, -1, 1, and 4. So those we can place onto our concavity sign line. And then I'm going to go ahead and fill out my concavity sign line, and the slope of my f prime graph is going to correspond with the concavity of the original graph. So negative slope on the f prime graph was going to translate to the original graph displaying concave down, and positive slope on the f prime graph is going to translate to the original graph displaying concave up. So here we can tell that here from -4 to -3, that's a negative slope. That's going to translate to concave down. Positive slope between -3 and -1 is going to translate to concave up. -1 to 1, that's going to negative slope is concave down. 1 to 4, positive slope, concave up. 4 to 5, negative slope, concave down. So based off of the second derivative sign line, then we can say our graph is concave down. Our original function has concave down behavior from -4 to -3, from -1 to 1, and then from 4 to 5 because f double prime is less than 0, or you can say f prime is decreasing. That is also fine. All right, part D, we have some order pairs of the original function. -4, order pair -4, 2, sorry, -4, -2, order pair at 0, 5, order pair at 5, 8. But now we're going to sketch a possible graph of f of x using information that we've gathered from slope and concavity sign lines. Okay, so I'm going to show the progression of developing or building this this f of x graph using a series of of steps. So with f prime, with my f prime sign line, first thing I'm going to do is I'm going to mark those order pairs that that the problem provides for us, just to kind of help give us some starting points and some target points, also points of reference for us. And I know that I'm just going to sketch a graph, just do a faint sketch based off of my f prime sign line. Again, the location is not important. The more important thing is that we're just kind of following along with the slope behavior of our sign line. So from -4, I'm going to rise until -3, and -3 I'm going to kind of level off a moment, because these are points where I'm expecting slope zeros. So I'm going to create the best as I can slope 0 at -3, and from -3 to 0 it's going to rise until it hits a relative max, hits a slope 0, decreases to a point where I'm going to call a relative min. Now, relative min doesn't matter where that point is. If you have it dip below the x-axis, that's perfectly fine as well. But I'm just going to just target a place for my relative minimum, and then from 2 to 5, I'm going to increase to my final order pair that's provided for us, which is at 5, 8. Now, I have kind of a general, very rough sketch of my graph here. This the slope is matching with my f prime, but my concavity is not where it needs to be. So we're going to kind of continue building off of this starting point. So off the second derivative sign line, I know that points of inflections are going to be at -3, -1, 1, and 4. So I'm just going to mark points on the path along the path of my graph, just as target points where potential points of inflection could exist. Okay. And now my last step is I'm just going to connect each of the points between my given points and these estimated points of inflection. I'm going to connect these points using appropriate curvature indicated by the second derivative sign line. So between -4 and -3, I'm going to connect these 2 points, displaying concave down. So here's my updated graph. I'm going to exaggerate these curvatures here. And then from -3 to -1, I want this portion to be concave up. Okay. From -1 to 1, from -1 to 1 through 0, it's all going to be concave down. And then from 1 to 4, concave up. And then from 4 to 5, concave down. So the dotted lines initially kind of just helps me see where my general path is, but when I get to this point, now I can connect those dots with a lot more detail in terms of concavity. All right, so now part D says sketch a possible graph for the second derivative function. So the second derivative function, I'm going to base it purely off of the second derivative sign line. Okay. So something to keep in mind is I'm going to mark my my x and y axis with indications of what each portion represents. So anything above the x-axis represents where my original where my f double prime graph is going to indicate concave up. Anything below is going to represent where I want the graph to show concave down. Remember, anything on the y-axis it now doesn't represent order pair of the original function, doesn't represent the slope of the original function. It represents the concavity of the original function. So anything on the x-axis is going to represent where point of inflection is, which is concavity value of 0. So first up is plotting the X intercepts, so -3, -1, 1, and 4. And now I'm going to connect these dots with the appropriate locations of the graph. So between -4 and -3, I want the graph to be existing below the x-axis. So we can start by moving up towards this point. We know the graph has to connect through these points. And then from -3 to -1, I want my graph to be all above the x-axis because it's going to display concave up. But I'm going to have it go up to some point and come back down because it has to be able to come back down to this point because we know this point is already identified. Between -1 and 1, concave down, so below the x-axis, but I'm going to have to come back up again to reach this point. Between 1 and 4, concave up. Has to be all above the x-axis, but then it's going to come back down to this point, and then from 4 to 5, concave down. So it's going to have to be in this region, so going to go back down below the x-axis.